All right, good afternoon, guys. Just doing a recording of our lesson for Thursday here a little bit early as I sent you a message. I'm going to be out tomorrow, so we won't have the live lesson. But I did want to go over our factoring notes, make sure everybody's got that information, and maybe do some practice problems on IXL. So we should be looking at the notes here on this video. And I want to talk about that zero product property first. So what this is saying is that for every real number, all right, any number basically other than an imaginary number, if we call one number A and the other number B, then if we multiply them together and get 0, then either A or B is equal to 0. Could be both are equal to 0 as well. So that goes for any type of factors, not just numbers themselves, but factors of any kind. So if we're talking about multiplying two monomials together and it's equal to 0, then one of those monomials is equal to 0. If we're talking about multiplying two binomials together, or a binomial and a monomial, then and they're both, and when we multiply them, their result is equal to 0, then one or both is equal to 0. So that's what we're using in this section to justify solving these equations when they're equal to 0. Excuse me. So with the practice problem, we've already done the example problem in the other videos. So if you didn't watch those, please go back and do that at this time. But we're going to go over the practice problems. And when we have a situation where we have a two-term polynomial, a binomial, technically, and each one is the basic form of this. Let's say, for example, this basic form is ax squared plus bx plus c equals 0. That's the standard form of a quadratic equation. So if it's missing this term, then we really only have ax squared and bx, and that's what we have here is ax squared and bx. So that's equal to 0. So to factor this, we would need to break it into just the GCF. So whatever the GCF is. And when we have an ax squared term and a bx, x is always going to be part of the GCF. So the other part is going to be whatever the numbers are. So in this case, 2 and negative 10 have a common factor of 2. So that's our GCF. And what's left after we factor that out, if we factor out 2x from 2x squared, what's left is an x. And if we factor a 2x out of negative 10x, we get a negative 5. So that whole thing is equal to 0. And going back to our zero product property, that if we think of this as A and this as B, and we're multiplying those things together to equal 0, that means that one of these two factors, either 2x or x minus 5 equals 0 if when we multiply them together, they equal 0. So we're just going to separate this up and say that 2x could equal 0 or x minus 5 will equal 0. So this one, we're just dividing by 2. So 0 divided by 2 is just 0. So that's one solution there. And then we would add 5 here. So x equals 5 is the other solution. So those are our two solutions, either 0 or 5. And if we were thinking about what that means, actually, what that means is that these are going to cross the x-axis at 0. Now, one thing I want to point out about this solution, and you probably noticed it if you watched the example, is this one also had an x equals 0. And the reason for that is when you're missing that c term, if you remember in the parabola version of this, if it was ax squared plus bx plus c, or y equals that, if it was the function form instead of the equation form, then this c term would be the y-intercept. Well, if the y-intercept is missing, that means that the y-intercept is 0, which means it's crossing at the origin. So it will not only cross the y-axis at 0, it will also cross the x-axis at 0. So really, when you have this type of situation where you're missing a c, you should know that one of your factors is just going to come out as 0, and the other will come out as something else. All right? So let's take a look at this example real quick, and then we'll continue on to the practice. Because let's just get a little closer to that so we can see a little bit better in the picture. There we go. See if it will focus for me. Sort of. There we go. All right. So for these, all right, this goes back to our factoring of a trinomial into two binomials. And so we're going to be using our rules about signs and what are the factors of the final term and factors of the first term that help generate that middle term. So in this case, we're going to look first at that sign. This is a plus sign is going to tell me that we have the same signs in our binomials. Okay, and this one, when that happens, when they're the same, this one tells us what type. So these are both going to be, both signs will be a plus sign. Okay, so in our binomials, I'm going to have a plus, and then because there's no leading coefficient, I'm just going to have an x and an x, okay? Now I'm looking, and this is all equal to 0, sorry. So what I'm looking for are the factors of 8 that will add together, because it's not only telling, this second sign not only tells me what, whether the same or opposite signs, but what's my operation I'm doing to get to that number. So I'm looking for the factors of 8, either 8 and 1 or 4 and 2 to give me that middle term. Well, obviously 4 and 2 is the one that adds to give me 6. So I'm going to have those two factors. Right, and then from there we would set that up and do that. Now this was already in the other video, so I don't want to necessarily do the whole thing there. I just wanted to refresh your memory again on how we're using the signs. So let's take a look at the practice on this one for that situation. So once again, this sign is a negative. We're looking at the second sign first to tell us what we have. So this is going to mean opposite signs. All right, and this sign, again, when we have opposite signs, tells us what the bigger factor sign will be. Okay, so the bigger factor, larger factor will be a plus, is what that means. Okay, so in our binomials, I'm going to, again, I don't have a leading coefficient, so I can just put x plus for one and x minus for the other because we have the opposite signs. And this is all going to equal 0. So from here, I'm looking for the factors of 21 that will subtract to give me 7, or 7, 4. So my choices are the middle factor pair of 7 and 3, which works. The other option would have been 21 and 1, which wouldn't. So the bigger factor is going to get the plus, so the 7 will go here. The 3 will go here. If we just check it with FOIL, right, that's x squared. That's negative 3x, that's 7x. So that outside and inside combination do give me the 4x that I need. And the last term is negative 21. So the FOIL works when we check it mentally there. So now I'm not done. Once I'm factored, I now need to use the zero product property and say that one of these factors or the other is equal to 0. So I solve both of those binomials for 0. And so this is going to be minus 7 on both sides. So that's going to wind up being x equals negative 7. I'm going to add 3 to both sides here, and x would equal 3 for that to be the case. So those are my two solutions to that problem. Okay. So the next part of this is going to see what happens when we have an A term. Right? When we have an A term, the likelihood is that we're going to wind up with at least one of our solutions as a fraction, if not both. Okay. So when we have a term that's something other than 1 or can't be factored out completely by a GCF, then we are going to usually wind up with at least one fraction. So First thing I want to point out is in this example, this is not equal to 0. We cannot solve these until they are equal to 0. So first thing I would want to do in that example, and we did this on the video, is we would move that over by subtracting 88 from both sides, right? So minus 88 there. And so I would get this expression or equation first, and then begin to factor it, right? And that's in the videos themselves. So let's look at the practice problem and go over that one. So once again, I am looking for, this one already is equal to 0, so I don't have to do what I did in that first step up there. However, if this wasn't equal to 0, I would need to move whatever's on this side over there. So whether it's an x term or an x squared term or a constant, either way, I got to subtract it or add it to move it to the other side. Once it's equal to 0, then I can begin trying to factor it. So I'm going to have two binomials in this trinomial setup. This sign, all right, again, is going to tell me that I'm going to be having the same signs in my binomials. And the first sign then tells me what type. All right, so both signs here, whoops, that's a weird H, sorry about that. Both signs are plus signs, addition signs. We have a coefficient on the first term, so I need to leave some space in front of my x's, but I'll put x and x as well. Now, this term is going to be made up of factors that make this. So 1 and 3 are the only factors of that. So my options here are 1 and 3. Here I've got 2 and 3 as my middle factor pair, and 1 and 6 or 6 and 1 depending on that. So I'm going to go ahead and place this one because it's already got the same sign, so it doesn't matter if I put the 3 here or the 1 here. It won't affect anything because of the same signs. I'm going to go ahead and place that because it's the only factor pair option available. Now I need to explore whether or not I want to do 1 and 6 or 2 and 3 and where those things go. This number in the middle is not very big. Remember when I said in last unit before break that when we have a smaller number in the middle, especially when we're adding to get to it, right, this outside and inside combination is going to add to give me the 11. I don't need a very big number necessarily to get to 11 at this point. So I'm probably going to explore the 2 and 3 option before I look at 1 and 6. So if I put a 2 here and a 3 here, right, I would have 2 times 3 on the outside, so that's a 6, and 1 times 3 on the inside, so that's a 3. 6 plus 3 does not give me the 11. So if I flip locations and do 3 and 2, now I'm doing 3 times 3, that's 9, and 1 times 2, that's 2. 9 plus 2 does give me the 11. So that is the combination I want, a 3 there and a 2 there. And again, keep in mind this whole thing is equal to 0. We're not just factoring these. We're factoring to solve. So now I need to actually split this up into the two equations. So 3x plus 1 could equal 0, or 2x plus 3 could equal 0 if by multiplying them together they equal 0. So just going to solve both are two-step equations. So I'm going to subtract 1 and get 3x equals -1 on this side. And then let me just move this camera down so we can see a little bit more down here. So then we're going to divide by 3. So here x is equal to 1/3. All right, don't change that to a decimal, just leave it as a fraction, it's easier. All right, going to subtract 3, so I get 2x equals -3 here. Then dividing by 2, right, x equals -3/2. I would think on IXL, they would be fine with the improper fraction there. If you put it in as a mixed number and they're not asking for that, you're probably going to get it wrong. So pay attention to what they're asking for. If they're asking for proper or improper fractions, please put them in that way for your IXL section. Speaking of that, let's go take a look at the IXL section and do a few practice problems from there. So here, this first one, and we'll do this on, we'll just copy these and put them over onto the whiteboard here. So let's just copy this problem. And we'll paste it onto this whiteboard. I'm not sure if it'll paste in the right format, but let's see. Close enough. So let's get to this. Nope, I don't want that there. All right, so that's m squared. Obviously, we saw that on the IXL. It's putting it as m2, but it's really m squared plus 41m equals 0. All right, keep in mind that whether it's x or m, it doesn't really matter here. We're just solving for that variable. So when we have this, right, this is missing the c term. So I think the first few type of questions you're going to get are going to be like that first example where you're missing the c term. So in this problem, we're just looking for the GCF. Well, if there's no number here, the only GCF is the variable of m. All right, so we get m, and when we factor that out, we're left with m on the first term, and then 41 on the second term, and that's equal to 0. Using the zero product property rule, we say that each of these factors could equal 0. So this one is already solved, right? We've got m equals 0. This one, we would subtract 41 from both sides and get negative 41. So those are our two solutions. All right, keep in mind this again right here, the m equals 0. When you're missing that c term, that's always going to be one of your solutions. Okay, so really what you're trying to figure out is what's left and what it solves to. Okay, so let's clear that off, and we'll do another question here in a sec. So let's go back over to IXL and just look at how we need to enter that information so we're doing it properly. So we're sharing the right screen here. Just double check that. Yeah. All right, so that's the screen we are sharing. So for this one, it says to write each solution as an integer, proper fraction, or improper fraction. So don't use decimals, don't use mixed numbers for your solutions if they are improper fractions, okay? And don't use decimals if you got a proper fraction. So if there are multiple solutions, separate them with commas. I believe most of these are going to come with two solutions. I don't know that they're going to give you any that are one solution, but you may, so just pay attention for that. And the other was negative 41. So we would put that in with a comma instead of two separate boxes for the different solutions, all right? So we just hit submit, and notice they're going to give you another problem similar to that for a little while. All right, so we're going to jump a level here and take a look at something like this one. All right, this one is a similar type of problem. However, let's just copy this over again and paste this on, and I'll share this screen with you. Come on. All right, there we go. And back to our whiteboard. All right, so this one, excuse me, was again 37. Oops, I don't want the eraser, I don't want the mark. So 37h squared minus 34h equals 0. All right, so this one, again, doesn't have a c term, so we're just going to factor out a common factor. Well, 37 is a prime number, 34 is not, but they don't share any factors. So we can't take that 37 out of there, but we can take the h out, which would be the common factor, and be left with 37h minus 34 in the parentheses equals 0. All right, again, setting these, I'm going to just come over here. So we've got h equals 0, that's one solution. And then the second one would be 37h minus 34 equals 0. This one we have to solve actually. So we would add 34. 37h equals 34. then divide by 37. All right, and that then, I'll just highlight it. This here, 34/37 would be our second solution. All right, so to go along with this one, this is our second solution. Okay, so even if they're weird fractions, you can still get a weird fraction. It's okay. Don't question the oddity of the fraction necessarily, okay? And let's go back over here and take a look at the next set of problems. All right, I'm not going to actually put that in. I'm just going to jump ahead here. All right, so here we have a, excuse me, this one that has an A term. All right, so this one, put it on our whiteboard again here. I'm just going to move that up a little bit and share this screen back with you. All right, so really what we have, again, it just gave me a 16H2, but that's really a squared term instead of a 2. And so I need to factor this one. Now, one thing I want to pay attention to is if we recall, some of our trinomials are what we would call perfect square trinomials. And this 16 at the front and this 25 at the back might indicate that this is a perfect square trinomial. So how can I tell perfect square trinomials again and check to see if that's what we want? You could use regular factoring methods as well, but sometimes it helps here. So perfect square trinomials where we were taking a plus b and squaring them, right? Two of the same binomials and squaring it gave us a squared plus 2 times a times b plus b squared. Well, that definitely looks like a squared term because of the 16h squared. This looks like a b squared term because of the 25. They're both perfect squares. If I just kind of check to see if what a would be, I'm taking the square root here. So a would actually be 4h if that were the case, and b would be 5. If I double it and multiply them together, do I get 40h? So 4 times 5 is 20. Doubling it, because that middle term in that formula would tell me that yes, that is a perfect square term. So really what I have here, excuse me, is 2 of the same binomial. I have 4h plus 5 times 4h plus 5 equals 0. Well, I'm not going to set both of these equal to 0. Only one of these things actually needs to be set equal to 0 because they're the same exact thing. So if I say 4h plus 5 equals 0, this is where I said most of these are going to have 2 solutions, but this particular problem where you have 2 of the same binomials getting multiplied together would actually only give you 1 solution. So in this case, I'm going to subtract the 5. I get 4h equals -5, and then I would divide it by 4, leaving that improper fraction as my answer, -5/4. Okay, so if you wind up with 2 of the same binomials, if you wind up with a perfect square trinomial that you want getting factored, you'll only have 1 solution there. All right, so pay attention for those and don't put in -5/4 twice. All right, it's probably going to count you wrong if you do that. All right, so let's go back over here and get another problem from IXL. All right, so we'll skip ahead here a bit again. All right, so we're into the 80s. Now this one is what I'm talking about as far as getting things all onto the same side. So I'm going to copy this again. I'll paste it over onto my whiteboard. Clear that whiteboard first. Did that already, actually. So let's, oh, that's weird. It did something weird for me here. Let me just double check on IXL what it's showing. So negative 6 plus 51q squared equals negative 45q. All right. So I'll show you what I'm talking about here. Switch this over to the whiteboard because it pasted very strangely. So I'm just going to rewrite it and then get rid of that thing there. So it started off, oops, get to this. So it started off with negative 6 plus 51q squared equals negative 45q. All right, so that's what that is. So let me get this off of here. Trash that. Okay, so first thing I want to do is get this thing into standard form of a quadratic equation. I need it to equal 0, and I need q squared first. So I'm going to put, what I'm going to do is add 45q to both sides to get it to equal 0 over there. And then I'm going to just rearrange all this into standard form. Okay, so I've got a negative 6, I got a 51q squared, I got a plus 45q. So I'm going to put it into standard form, move this over a little bit here. So I get 51q squared plus 45q, and then that minus 6 is my c term, and then this is all equal to 0. All right, so we have that. Now, process goes to factoring. So this is a negative sign. All right, I have a coefficient on the front, so I need to leave myself some space for these q's. I'm going to have a plus sign, and I'm going to have a minus sign because this is telling me that I have, this one's telling me opposite signs. Okay. This is telling me that the bigger combination of either outside multiplication or inside multiplication is going to be positive. So my bigger factors I want to put in here since this is the plus. Okay, I'll put the plus here. So my inside combination is going to be the plus. My outside combination would be the negative. Let me finish that parenthesis there. So we've got that. Now, this number of 45 is getting, I need to get there through subtraction. Okay, that's what the other thing this second sign tells me. I'm going to get there through subtraction, which means I probably need to use a bigger factor. Well, 51 is a prime number. Actually, not a prime number. It's divisible by 3 as well. But to get to 45, if I'm subtracting, I may actually need to use 51. Right, so my factor options are 51 and 1, or 3 and I believe 17. Yeah, 17. So those are my options. So to get to that, I could do 17 times 6, but that's probably going to be too much. And the other thing I want to point out is something I pointed out when we were factoring. Look to see if these two numbers, if you were just to add them together, right? If I were to add 51 and negative 6 together, what do I get? Well, what I get is 45. So I need to actually use those two numbers because it's going to get me to that. So I really need to figure out how to make that happen. So what I'm going to do is my first number, again, the inside combination needs to be the bigger combination. So 51 is going to go here, 1 would go there. The other combination I need is 6 and 1. All right, so remember when these things add together, they actually appear in the same binomial, and the other binomial just has 1s in it. All right, so that's all equal to 0. So we're going to set this up, just call this q plus 1 instead of 1q plus 1 equals 0, or 51q minus 6 equals 0. Going to subtract 1 here. That one's just a one-step equation, so there's one solution. This one's a two-step equation, so we need a little bit more work here. So we're going to add 6. Now, keep in mind that this is divisible by 3. I set it over here. So is 6, which means we're going to need to simplify this fraction when we do that. So please pay attention and don't put a unsimplified fraction in as your answer, it will count you wrong on IXL. Okay, so simplify this by dividing both of these by 3. When you do that, you get Q equals that divided by 3 is 2. Obviously, I said over there 3 times 17, so 2/17 would be your second solution. So -1 and 2/17. All right, so hopefully that covers the majority of the type of problems you'll run into. If you need some assistance, we'll still continue to work on this actually through Monday. We can go over the questions and things like that. If you don't get an IXL section done by Monday, we can go over questions that you might have during class or during office hours on Monday for me, okay? So hope everybody enjoys their long weekend, has a good Easter, and I see everyone on Monday. Fist bump. See you guys.